Hello and welcome back to Climate Solutions News Podcast. I'm Dominic Shales. Roughly half of global final energy demand is for heat, and most of it still comes from burning fossil fuels. Solar photovoltaics and heat pumps dominate the conversation, and solar thermal rarely gets a mention. But my guest today wants to change that. Christian Albrecht leads commercial development at Naked Energy, a British firm building the world's highest energy density solar collectors. And their technology heats water to 120 degrees Celsius to use in whatever ways that heat needs to be used. They have more than 120 projects live, including on the roof of the British Library in London. Christian, welcome to Climate Solutions News.
Thank you. Nice to be here.
Just to kick us off, why don't you give us a little bit of background about yourself and how you ended up doing the role that you're doing at Naked Energy?
Sure. So I'm the group business development director for Naked Energy. I've been with the business for nearing 6 years now. Have been responsible for leading the commercial function, so sales, partnerships, for a number of years. And I've spent, I guess, the last 15 years, so my entire career, working in commercial roles for energy technology and sustainability services companies. So initially in the built environment, building energy efficiency retrofits out in the States originally, and then moved back to London and worked in consulting for a few years. Following that, led commercial development in Europe for a Australian energy software company doing machine learning driven energy optimization for commercial real estate, doing projects for the likes of sort of O2 Arena, Hilton, Metropole London, etc. So lots of large, complex energy users, and then now in on-site renewables and heat decarbonisation. So we're working on large energy infrastructure projects across the world, all focused on delivering decarbonisation of heat.
Fantastic. Very good. So talk us through the technology itself, because many people won't necessarily have come across what it is that you do. They'll be very aware of solar panels, traditional solar panels on roofs, but you're approaching things slightly different. And also just explain how Virtue as a product suite
Yeah,
works.
sure. So most people will think of solar photovoltaics when they think of solar, especially in the UK. That this is a solar technology that generates clean, renewable power from the sun's energy. Solar thermal as a category of solar energy is actually older than solar PV, and is it's quite a large market, but it's not really one that's got a lot of traction in the UK, maybe due to limited sun that present times excluded. But if you travel through southern Europe, Greece, Mediterranean, you'll often see these systems on individual dwellings. You've got like a drum and a panel that sits on the roof. This is a archetypal solar thermal collector producing hot water from the sun's energy. It's really cheap and efficient and obviously renewable way of generating hot water for showers, for kitchens, etc. And this is the majority of global capacity for solar thermal is in that residential sector. What we do and where we see the biggest opportunity is actually in the sort of next generation of these products. So a more advanced, engineered solution for the commercial, industrial, high heat consumers. So, obviously you have hot water needs in a home, but you also have them in a hospital or in a hotel or in a manufacturing site. And this represents actually the lion's share of global heat demand in these sort of commercial industrial sectors, and also a very large portion of global emissions and one of the hardest sectors to decarbonize. So our technology and our commercial efforts are focused on using advanced solar thermal technologies. So a next generation of solar collector using vacuum tubes to produce higher temperatures, and pairing that with digital platforms for design and monitoring to unlock larger, more complex systems with higher temperatures and more sort of commercial user requirements. So you mentioned 120 projects. We're delivering renewable heat for very large hotel chains across Europe, supplying hot water for the showers, the kitchens, the laundry, the catering, the swimming pools, the spas. Yeah, this might be over 50% of the energy demands of a hotel can be met by these systems. And on the other side, obviously, we're looking at those industrial users. So large breweries, large pharmaceutical companies, pulp and paper, food and beverage manufacturing, where they have process heat demand year round. And we can address those through renewable heat provided by the sun.
And you talk about the carbon savings that comes from your solution, and I've read that you reckon that solar thermal can generate between 2 and 10 times the carbon savings of conventional solar. How can that be? Talk
Yeah.
us through the sort of calculation.
So the obviously there's a big variance between 2 and 10%. It depends on a few factors. But
Sorry, is
the
it 2 and 10% or
two
two
and ten
and ten
times.
times?
Sorry, you're right.
Yeah,
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 yeah, yeah.
yeah.
Good catch. So the difference is driven by two factors. One is the efficiency of the collector, and the other is the emissions factor of the displaced energy. So solar thermal as a category is inherently more efficient than solar PV. So people will have heard of PV efficiencies increasing from 22% to 23 or 23.5 and having these, sort of incremental efficiency gains. What that means is that over 100% of energy that the solar panel receives, it converts 23% to power. The rest of the sun's energy is converted to heat by a PV panel, and that heat just makes the panel hot and it radiates out to the atmosphere. So all that energy is lost. Solar thermal is able to just by virtue of the physics of the product and the spectral wavelength of the sun's energy, solar thermal is able to capture a larger portion of the sun's energy as usable heat, and that gives it greater total efficiency. So solar thermal collectors can have efficiencies of 60, 70, 80%. And what that means, of course, is converting a lot more of the sun's usable energy into useful heat on site. So if you've got 1,000 square meters of PV panels versus 1,000 square meters of solar thermal panels, you're getting a lot more energy out of the solar thermal panels and therefore achieving a greater um, quantum of carbon savings. The other portion of it, of course, is the emissions factor of the displaced energy. So in the UK, the grid is quite clean. It's getting cleaner every year through the introduction of new, utility scale renewable assets like solar PV or more wind or whatever else it may be. Um, and of course, you have a declining emissions factor, so kilograms of CO2 per kilowatt hour. The emissions factor of fossil fuels is fixed based on the calorific value, the energy content of the fuels. So if you burn a kilowatt hour of gas, you produce an emissions factor that is fixed and is not decreasing over time. And what we see in increasingly in places like the UK is that the emissions factor of gas is higher than the emissions factor of the power. And then if you map those over the longevity of the installation, so a 25-year lifetime of the solar equipment, you'll see that the emissions factor of displaced gas, of course, is fixed, and the emissions factor of the electricity is expected to decline according to government projections to the point where it's almost zero. And the solar PV is not saving any carbon. It is reducing your bills, but it's not saving you any carbon because the grid is now clean. So in places like the UK or even Switzerland, where the grid is very clean through lots and lots of hydro power, we can deliver an order of magnitude more carbon savings than a conventional solar photovoltaic array.
And in terms of installation on roofs, solar photovoltaic can only take up a certain proportion of the roof space. Typically, I think is about 50% or something. But you can go broader. You can take up more of the available roof space to put on your technology. Why is that? What's particular about your product that
Yeah.
allows that?
So that's, I guess, one of the unique characteristics of our solar thermal collectors is the geometry of the collectors. So most solar collectors are oriented facing south, and that means that you have a collector that's pitched off the roof, which provides shading on the collectors behind, and that necessitates what we call inter-row spacing, which is a corridor between the rows of collectors to prevent shading and losses. And that means that you have a pattern density of collectors that is limited to this size of the collector plus the size of the space in between them. So you have this utilization factor of roof area around 40 to 50%, which is maybe lower in southern latitudes, close to the equator. You can pack more collectors, and in more northern latitudes, bigger spaces due to bigger shading and that sort of 40% utilization. What we do is we orbit our solar thermal collectors east to west, and then tilt the absorber to the south. So we have a different configuration in the array, and that obfuscates the need for inter-row spacing. So you can cover the entire service area with generating assets and minimize that wasted roof area. So achieve a greater packing density of about 85% utilization of array area, and more energy generation and a greater offset against the fossil fuels and commodities.
And obviously, planning regulations vary across
Mm.
countries, across local authorities. How are you getting, or what's the reception from planners to your solution? Are you finding them welcoming? I mean, if we look at the UK, there's quite a lot of restrictions on roof technologies generally, but is there a new understanding of the importance of these, and are you getting flexibility in
Yeah,
your for your installations?
you'd sort of hope that in a declared climate emergency across like 98% of councils that planning for solar would ease through, right? Um, we uh, we fall into permitted development. If we look at the UK specifically, the collectors sit flat on the roof, so you fall into permitted development for um, most installations. We have had to deal with planning for specific projects. So you may have seen, we've got our collectors on Wimbledon at the tennis championships. We're on a pitched roof there, so not uh, sort of party to permitted development when you're on a pitched roof, and that meant seeking planning. But obviously, the Merton Council, responsible for approving planning, is also declaring a climate emergency, so we're keen to sort of push through these schemes. Similarly, with the Mandarin Oriental Hyde Park project, this is in Knightsbridge. You're on Hyde Park. This is an area of specific sort of interest and heritage buildings and conservation buildings and considerations. So we did need planning permission there, but we found that the approvals have been you know you have to navigate the challenges, but have been reasonably straightforward. British Library was a bit of a different matter. This is a Grade 1 listed building in the middle of central London. You've got the St Pancras Renaissance Hotel, directly overlooking the array. And this is the largest solar thermal project ever in the UK. So that was a bit more complex. We had to go through Historic England for approvals. We had to conduct glint and glare assessments to demonstrate the lack of impacts on nearby buildings. So it's quite a robust process, but of course, you've seen the system on the roof, so we were able to navigate that, and that I guess serves as a demonstrator of what's possible in some of these historic buildings.
Just to explain, before we started this recording, I was saying to Christian that I actually saw the array last week from above, from an opposite building. Yeah, had I not known what it was, it wouldn't have struck me. But it's great that it's there. You're really going for the trophy buildings, aren't you? Is this a deliberate a deliberate strategy so that you get the the PR rub off of these
I guess so.
good
Yeah.
projects?
I mean, there's a few there's a few considerations there. One is our product is uh, it's quite a nice looking architectural feature, we think, compared to conventional solar, and as a result, lends itself to certain types of sites, right, that have considerations around visual impact. So the Mandarin Oriental Hyde Park is it's a very, very nice hotel. I haven't had the luxury of staying there, but I've visited a few times for work. So um, there is a consideration there on the type of technologies they put in the building and what that looks like, and I think that lends itself towards our product naturally. But it's not just something that's suitable for these high end buildings. We are doing large industrial, large utility sites where visual impact isn't important, and that's where, of course, the energy density is the key consideration. But yeah, high profile buildings do help us garner more eyes on what we're doing as a business. Not everything is as high profile as the British Library or Wimbledon, but we do have a multitude of other leisure centre sites or other hotel or office or industrial and commercial applications. But those ones are they're nice wins, and they look nice on the website.
Definitely. And you've launched a heat as a service model with E.ON recently. Tell us a little bit about how that works and why you've done it.
Yeah. So E.ON are one of our lead investors through a division of the business called Energy Infrastructure Solutions, which is a large group operating across Europe in 16 different countries. And they have an interest in owning and operating complex energy centers and energy assets for heat networks, for large industrial, commercial sites, etc. And obviously through our partnership with them and their equity stake in our business, we are looking at how we can give access to the technologies to their customers, and also more customers that they can energy engage with directly through our own efforts and through our other sales channels and partners. And one of the big challenges in the industry, especially if we look at these larger energy consumers, is the cost of decarbonisation. Not just the price of energy, but the level of investment required. So if we look, for instance, at a large industrial site, a big brewery or food manufacturing site, the energy demands, the size of the plant, the level of intervention to move this site from you know steam fuel boilers to a low carbon solution, be it solar heat pumps, solar thermal, solar PV. These integrated solutions that are often multi technology. There's a large level of investment there. We're talking about, um, we're working on one project in Europe presently, which is 28 million euros of investment. It's a large infrastructure project to build and install these assets. And the way that we want the customer to look at this is that actually it's about the cost of energy. So if you have a large investment in infrastructure and you can deliver a really low cost of energy through that infrastructure, when you amortize the costs of the commodities and the infrastructure over the lifetime, over sort of 25 years, your cost of heat from this system might be lower than what you're paying for gas, right? But you need the capital to invest in that in year one, which is the problem. And the energy as a service model, heat as a service model, enables us to sort of realize these projects for customers. So we can invest this money on their behalf, through our project team and our special purpose vehicle and our equity partners. And we can build the assets, design the assets. We can de-risk the technology selection. We can de-risk the operation of them, so we can manage the operation of these assets and supply energy to the site at a fixed price per megawatt hour, which is lower than what they're paying for gas. And this is an exciting proposition for these customers. They get renewable heat. They get the commodities benefit, the hedge against rising and volatile fossil fuel prices. They get to decarbonize and they get to manage that issue around how to capital towards these projects, because we're not ring fencing 20-30 million for a decarbonization project. We want to build a new bottling line in our factory, or we want to expand our distribution or open a new site. And they'd rather spend their money trying to grow top line revenues than manage decarbonization, and that's where heat as a service comes in.
I mean, the same issue applies for consumers in domestic situations as well. And the UK government did spend quite a lot putting in place subsidies and policy incentives for heat pumps. Um, have you had any support for consumer applications from the government? Have they even woken up to the potential of this technology yet?
Um, so, schemes like the British Library were installed through PSDS, so Public Sector Decarbonisation Scheme. So that was, a great initiative that ran for quite a few years up until recently. And, there's a number of projects that have benefited from that in the UK. I guess that the current standing of subsidy support in the UK for heat decarbonisation, there's no schemes currently available. We're obviously keenly looking at what might be coming in the future as a UK based business. But a lot of our work, by virtue of being a solar technology company, a lot of our work is in slightly sunnier climates, and we're really benefiting from subsidies across Europe, where there's strong mandates in Germany, in Austria, in the Benelux, in Spain, Portugal. There's good schemes available there. There's a currently recently sort of operating a scheme for industrial sites, a renewable heat auction, which awards you it's a competitive bidding process. You bid for your cost of CO2, and that's quite an exciting scheme. So you put forward your design and the cost of carbon, and you can win funds at the auction to support decarbonisation. And this is really a crucial a mechanism to support some of these projects, where gas has been subsidized for generations and has very, very, entrenched and well established, interests in infrastructure that keep, the prices reasonably low. The flip side of that's obviously good for business, but the flip side of that is it makes it very hard to decarbonize, because the cost of fuel is so low. To recover investments through energy savings is a real challenge. So, subsidies are in many markets, turning the business case from a no go into a yes. And once you start to scale technologies and solutions, obviously they become more competitive without these schemes, and that's that inflection point that we want to get to in the coming years.
I mean, given what you said earlier about the efficiency of solar thermal versus solar PV, you'd actually think that it would be a brilliant solution for the UK with our generally less sunshine. Not proving the point at the moment. The compared with rooftop solar PV or other forms, you'd have thought the government would be really trying to incentivize that as a practical solution.
Yeah, I mean, where we where we do find the business case makes sense in the UK, and is where you're looking at and I suppose more broadly than the UK as well. There's a really strong business case on uh, solar thermal with heat pumps, which is quite an interesting technology arrangement. So, one of the challenges of heat pumps is the cost of heat. So you're migrating from cheap gas onto a more expensive electricity tariff, right? So you've got this delta in the price per unit of energy. You do have a coefficient of performance benefits with your heat pump, which brings down your cost of heat from that unit, but the spark gap between the two commodities is roughly equal to the COP of the heat pump. So you end up with a parity between the unit costs of energy, but you've had to invest lots of capital to install the new system. So you've got no energy savings to recover your investment. And that just means that your payback on a heat pump project in the UK is 20, 30, 40 years. It will never pay for itself, right? Which of course is a challenge. How do you get approvals for these investments on the basis of those projects parameters? And what we find with solar thermal is a very low cost of heat. In fact, less than the cost of gas, and far less than the cost of electricity. But solar thermal suffers from different challenges, be it the irregularity of the sun and the ability to maintain constant temperatures in varying environmental conditions. And as a result, what we find is this really nice sort of symbiotic relationship when you combine the two technologies, where solar thermal acts as a heat source for the heat pump. So you install your solar thermal array, you have, as a result of that, consistent, warm energy in a thermal buffer vessel, which acts as a heat source for the heat pump. That, in turn, reduces the temperature delta on the heat pump, dramatically improves your COP, so it reduces your cost of heat very significantly, and lowers the cost of heat enough to generate a positive business case, while still being able to meet the seasonal requirements and that consistent temperature due to the constant availability of heat from the heat pump. So these sort of integrated solutions and hybrid solutions are where we see most of the business opportunity, or increasing business opportunity, especially in the UK.
Great. Let's just finally turn to the company. You mentioned E.ON as an investor already. You closed a £17 million Series B. So Barclays leading with E.ON on that. When was that, and what are your kind of plans to deploy that that funding, and when will you need to raise again?
Yeah. Um, that was a year and a half ago. We completed the rounds, which was, it's a complex process. It's a long process. But they're fantastic investors, very engaged and involved in the business, and very strategic as well in terms of the alignment and availability to sort of leverage those relationships to generate opportunities and growth and sort of enterprise value for our business. The use of funds is sort of ongoing. We've invested heavily in technology development. One of the exciting things that we'll be launching in the coming months is our Clarity 360 platform, which is a digital tool that enables customers and channel partners, design engineering consultancies, project developers, to design our system in minutes. It's a process that historically has taken days, if not weeks, to locate the collectors on a roof, to design and size the pipework, the vessels, and all the corresponding infrastructure, and generate yield calculations for the system. And this is a barrier to entry that has really, I think, stifled the growth of solar thermal, because of the complexity of the sort of systems development. And we've invested heavily in the development of this new digital tool that automates all of that, using a browser-based system to locate your building, populate it with collectors, automate all of the sort of algorithms that produce these calculations for system sizing and these key inputs for the customer technical and commercial proposition. And this is going to make this a lot more accessible. It's going to open up, huge opportunities for channel sales, which is really exciting for us. So that's been a big use of funds, and we'll be launching that shortly, which is really exciting. And then alongside that, we've invested heavily in development of two functions in the business. One is the commercial function, so growing the sales team and partnerships team. We now have dedicated people working in markets in Iberia, the Benelux, and the DACH region, which is really exciting. So working with local partners in local languages and developing local projects, which of course is really important to our customers. And then finally, on the design engineering team, so Naked Energy are a product R&D engineering business, so we develop the IP behind the technologies, but we also work on developing systems for our customers. And we've got a new design engineering team, which is really adding a lot of value into developing projects with customers and supporting our partners through their project development. And this is really responsible for the the detailed system engineering and specification of our equipment, but also these other hybrid systems and complementary technologies. So bringing solar thermal in with heat pumps, with heat recovery, with photovoltaics, with energy storage, and delivering a full integrated solution where solar thermal sits at the heart of it for these large energy consumers.
And
Um,
are you going to need to raise again, or are you kind of now cash flow positive?
So, to the second part of your question, Dominic. So, we are actually serendipitously presently completing a new round of investment. So, it's been a big piece of work over the last year or so, and this is a really exciting strategic partner. We can't say who that is yet, but we'll be hopefully announcing that soon. And this is a strategic investment in the business to unlock more opportunity and increase scaling and sort of pace of deployment. So we're very excited about that, and I guess watch this space.
Very good. So, Christian Albrecht from Naked Energy, thank you very much for joining us. I'll definitely be keeping my eyes out for more installations on rooftops. Sadly, not at Wimbledon this weekend. I didn't get
Yeah,
tickets, unless you can give me any.
no,
Um,
I can't get them myself.
I think you put across a very clear case for thermal heat as an unsung alternative to many of the existing sort of more celebrated technologies. You can find more details at nakedenergy.com and more interviews and climate tech news at climatesolutions.news. Please do share the show, follow us on our social media, and subscribe to get further editions of the podcast. So many thanks, Christian, and until next time.
Thank you.